Alright, hi, Technomano 5650, Technomano Central Boiler Plants approved for public distribution, Unlimited Headquarters Department Army, October 1989. What is it? Chapter 1, Section 3, Principles of Steam and Hot Water Generation. Basic principle of the generation of steam occurs to result two separately processed the combustion result for the heating and burning fuel, heat and transfer absorption of heat and water combustion was was discussed with the previous section of study, but the heat and transfer process can be made with the elementary boiler as shown in figure 1.7. But the boiler system can be represented with the container equipped with the outlet pipe with the valve, the pressure gauge, the thermometer immersed in water. The fire was built up in the unit with the water at 32 degrees Fahrenheit. It was put in a container with the valve left open with the water temperature would steadily as the fire burns until the temperature of approximately 200 degrees Fahrenheit is reached. At time the temperature was rise with no further, the water will gradually boil off, and the firing is continued long enough for all the waters will be evaporated. If the heat content fuel source is as accurately measured, if the heat content fuel source is actually accurately measured, it can be demonstrated that the raise of the temperature of 32 degrees Fahrenheit to boiling heat input was 180 BTUs for each of the pound of water. It was also shown that 970 additional BTUs each pound of water is required by the boil off all the water. Additional heat is called with the Latin heat vaporization representation. Heat required of converting with a small volume of liquid into a large volume of steam with the valve is closed and using another batch of water, repeating the process, allowing the pressure to build up to 100 psi's. Then the throttle of the valve with the pressure maintain 100 psi. The temperatures in the container will now approximately be 338 degrees Fahrenheit. This is called the saturation temperature of 130 psi G pressure. Heat input required for the raised 1 pound of water to 32 degrees Fahrenheit upon saturation, a temperature of 309 BTUs. Energy expanding of the boiler, 1 pound of water to 338 degrees Fahrenheit at the 100 pounds of psi, 880.6 BTU. The temperature required to boil the water increases as the pressure increases the amount of the heat put in the liquid to raise the boiling and to the boiling pipe temperature is greater than latent heat. The vaporization pressure progressively lessen the pressure included in the table 1.9 provided with the summary saturation temperatures, energy, water, energy, steam, latent heat, and evaporation, and pressure of the 0 to 300 psi's. Alright, 115, heat transfer. The heat transfer is accomplished with three methods: radiation, conduction, convection. All three methods are used with a boiler. Heating surface of the first furnace area, they receive the primary radiation. The remaining heating of the surface of the boiler receive the convection from the hot flue gases. Gases. Heat received the heating surface of the flue travel through the metal conduction. Heat is then transferred from the metal to the water with by convection. Each of these methods is discussed in more detail. Radiation is the most important method for heat transfer to the furnace. The amount of the heat transfer depends on the area of heating surface, the hot surfaces, and the furnace. The difference with the power of the temperature of the flame and the heating surface and the nature of the flame. The same temperature of the coal flame is more radiant than the oil flame, and the oil flame is more radiant than the natural gas flame. The same physical law governing transmission light is also applied with blood transferring radiant heat. Heat is transmitted in straight lines. Heat can be reflected and refracted. Heat is radiated in all directions. Radiation heat can be transmitted through a vacuum. Most of the gases, some of the liquids, few solids, the solid boiler tubes absorb the radiant heat from the flame, radiate the small portion of the heat back in the furnace. B. Conduction. The heat is transferred through the material with the individual particles staying in the same position. The heating flow of the iron bar when one end of the bar is held with the wire is a simple example of the process. Conduction occurs when the material is called the conductor in physical contact with both the heat source and the point of delivery. The heat flows from the hot end to the cold end of the conductor. It makes no difference if the conductor is straight, crooked, or inclined, horizontal, and vertical. The material in which it is made with the heat has greater effect. However, the metal conducted heat readily while liquids and gas conduct heat more slowly. Some materials conduct heat very properly and are called insulators. Common example of the insulator: asbestos, fiber, glass, wood, sometimes plastics. And the amount of heat transmitted always varies with the length of the path and contact area. The high temperature, with the amount of heat transmitted, it always varies the length of the path and contact area and the temperature differences. Convection. Transfer of the heat by convection can be compared with the brigade, in which each of the man carries water from the supply point to the tank. In the example, the medium represented by the man, the heat is represented by the water. In convection, with the gas and liquid mediums received from the source, expanding it is pushed away with the colder, heavier particles of the medium. The fluid which received the heat transfers the heat from the nucleation, losing some of the heat in process. It may be or may not return to its sources and to repeat cycle. The heat transfer convection normally occurs from a lower to higher elevation. However, the transfer in direction may take place in external force such as fans, pumps, and pressure drops is applied. Gas flow consideration. In most boilers, a large part of the absorbed heat is given off the hot flue gases which sweep over the heat absorbing surfaces. Okay, alright, let's go over this. Alright, 117 is elementary boiler: the fire, the water, the thermometer, the gauge, and the steam. Water, steam characteristics: pressure, psi, saturation, temperature, energy in the BTU per pound, energy in steam BTU in pound, and latent heat and vaporization. Alright, heat transfer takes place in convection, and the quantity of the heat transfer can be varied with the controlling the temperature quantity of the flue gas. Usually both control the ability of the material to resist damage effects for the high temperature of the limiting the factor in the first case of the force available to causing the flow through the boiler, limiting the factor in the second. The boiler draft loss is the resistant flow of the force and pressure drop required for gases to flow from the boiler. Draft loss is commonly called draft. It may be supplied with the chimney and forced draft fan induced with the draft fan. The draft, which measured in inches of the water, depends primarily with the velocity density of the flowing gas. The cross-sectional area with the length of the gas passage. Draft loss increases the square of velocity directly with the length of the passage. Thus, force required to maintain proper inflow increase for the four-actor of forward when the velocity is doubled by the factor when the passage length is doubled. It is important to keep the velocity on minimum consistent with the requirements of good conventional convective heat transfer. If the maximum output of the boiler installation is to be attained with the cross-sectional area, the baffled arrangement and length of the gas passage are usually fixed. If the gas passages are kept free of slash accumulation, gas velocity and the draft loss will depend solely on the quantity of the gas flow, which in turn depends on quantity of the air supplied to the burner and burn the fuel. The minimum air supply consistent with the good combustion practices therefore minimize the draft loss and help maximize the heat transfer and boiler output. Water circulation consideration. Water circulation of the steam boiler becomes the density of the water greater than the density of water and steam mixture. Reference to the figure 1.8 within the boiler, the more dense water falls, while the less dense mixture. Table 110 illustrates the relationship of the water and steam mixture at 15 psi, 100 psi, and 100 psi. As known in the table 110, volume becomes more smaller than pressure increases. Natural circulating forces are reduced, and the operating pressure of the boiler increases with the increase of the permanent of the steam, and the mixture increases. Hot water boilers normally use the pump the forced circulation water from the boiler because the density difference between the cold and hot water is not large enough to cause the natural circulation, which is the velocity necessary for good heat transfer. F. Heat transfer of the boiler tube and waters by convection. Heat transfer of the convection depends on the temperature and velocity of the gas on one side of the boiler tube, the velocity of the water on the other side. Heat can be transferred to quiet water at the rate of approximately 2.8 British thermal units per hour per square per foot per degree Fahrenheit. The temperature difference. Increasing the velocity of water aids convection, increasing the heat transfer about 1,500 BTUs an hour per foot squared at Fahrenheit. This is due with the very thin film with the stagnant water with which is the contact with the boiler tube. They can be demonstrated with a simple experiment that using the Bunsen burner and a metallic vessel containing the boiling water shown in figure 1.8. Place the lighted burner under the vessel. Observe it closely. Note that the flame spreads in the sheet of above 1/30th to 1/40th of an inch from the vessel. Because of the high conductivity, the temperature of the tube is only a few degrees higher than the water, while the temperature of the burner flame is much higher. Therefore, there must be larger temperature to drop than through the film than between the flame and the vessel. The principle applied for both the water and gas side of the vessel. The heat of the boiler tube was conducted through the thin stagnant film of the water before the active convection of the process begins. Heat transfer can be greatly increased with the film and reduced with the thickness eliminated completely. Usually, this accomplished increase the flow of velocity across the surface, scrubbing the film away. Unfortunately, as was mentioned earlier, the increase of velocity, including an increase of the draft loss, the power requirements of the thin film does not effectively irradiate the conductive heat, but only convection heat. G. Optimizing heat transfer. Boiler furnace heat with the absorbed combination radiation convection of the absorbed heat to absorbed heat conducted through the boiler tubes. Water to the boiler tubes is heated by convection. The tube, either by the heating surface of the closure of the fire, do not have a higher rate of the glass flowing across the receiver. Practically all heat and radiation heat sources. Heat surfaces close to the furnaces across the gas flow in the higher receive the both radiation convection. Surface distance for the furnace receives all their heat by convection. Heat transfer that can be optimized to control excess air, keeping the boiler clean and maintaining optimum gas and water velocity. Alright, L. Excess air control. The rate of which the radiant heat is transmitted varies with the fourth power of the absolute Rankine temperature. Rankine temperature is based on a scale of 0 presents the complete absence of heat. 0 Rankines is approximately minus 460 degrees. To convert Fahrenheit to Rankine, add 460 degrees to the Fahrenheit temperature. The amount of heat transmitted with the radiation doubled with the absolute temperature of the radiant source increased with approximately 19%. The rate at which heat is transmitted with the radiation fuel made of the temperature of 1050 Fahrenheit or 1510 Rankines, and can be doubled and increased with the temperature of the refractory of the wall bed with 1350 degrees Fahrenheit, 1810 Rankines. The rate of the heat and the transmitted of the radiation of oil flame that can be increased with the 42 degrees Fahrenheit, 42% increase with the temperature of visible flame of the 1725 degrees Fahrenheit, 1920 degrees 5 degrees Fahrenheit, or 2185 degrees radiating, and to 238.5 Rankine. Our table 110 shows the water-steam mixture and mixture of steam and water of the specific volume, cubed pounds of pressure at 1500 and 1400 psi. The volume ratio of valve mixture over volume of water pressure per processor psi, 1510 and 400. Alright, water circulation. This shows the loop with a Bunsen burner on the gas supplying the from on the coil on the bottom of the water heating through a tube. The water goes from the tube and the steam rises out, and the water goes in circulation in about 10 inches. 1.9 effective suit and scale on transfer. Boiler tube with boiler tube metal wall. Water side T2, T1. Temperature 1 and 2 needed to transmit the same amount of heat in the tubes and dirty. Suit and scale. Boiler tube metal wall. Water side T2. Temperature 2. Temperature 1 gas side. Reduce the excess air used for the combustion of the fuels cause of the flammable temperature increase. The maximum flame temperature normally obtained with approximately 3 to 5% excess with the moderate increase of the furnace temperature resulting from the excess air reduction marked effectively with the amount of radiation absorbed with the boiler strip. To maintain a clean boiler tube, the amount of the transfer to conduction depends on the type of thickness conduction of the conductive material, as well as the difference of temperature. Heat is readily conducted through the metal, and while ash, suit, and scale are poured with conductor. Figure 1.9 illustrate the effect of suit and scale. The heating surface between becoming coated with the soot and scale and the material. The firing range for the boiler must be increased with the raise with the grace gas temperatures. Maintain the same amount of heat transfer than any deposit on any other side, but the heating surface increase the maintenance cost, reduce the efficiency, because the operator injuries, boiler damage, and the tube of the overheat for the rupture. Reference to paragraphs 316D and 334 further information. 3. Maintaining gas and water passages. Keeping the gas passage free of accumulation for the soot and ash. Maintaining the gas baffles is a good repair, helps increase the proper gas velocities to all heat transfer surfaces. Keeping the water passages free of the accumulation of sludge and scale. Ensure the proper water flow with the velocity for cooling of heat transfer surface generator steam with the hot water, maximum water versus economical heat transfer. Maximum economical and economical heat transfer are not the same. It is rare possible to operate with the boiler at temperatures highly enough to obtain the maximum heat transfer rate because of the material limitation, particularly of the furnace brickwork, the maximum temperature of which can be safely managed and determined by among the consideration kind of fine fire break used in the furnace construction self-supporting, supported with the quantity of the kind of the fuel, kind of ash and fuel furnace size, the amount of the type of the cooling with the furnace wall, the air cooled and water cooled. It's important to maintain low gas temperatures in the boiler outlet since of the result of the higher boiler efficiency. However, the rate of the heat transfer may be relatively low in the area because the rate temperature difference is low. The practical limit of the velocity of flow gas based on responsible fan horsepower requirements class capabilities discussed in paragraph 115. D. Water velocity fixed in boiler design cleanliness for any of the particular fixing firing rate, reduced water velocity, lower boiling fire rate, resulting in reduced more economical heat transfer rates. Most of the above factors determined by the design of the boiler is responsible for the boiler manufacturer to balance the requirements of maximum heat transfer with the econ and produce a cost-effective design. Chapter 2, Description of Equipment, Section 1, Boilers and Heat Exchangers.